Students, and this lecture is about area with the help of finding area with the help of definite integral. So this is area under curve, area between two curves. We can evaluate this area using the formula for definite integration. So these are the things this we have discussed before, that this is the area that we have discussed in the in the definite integral as a limit of a sum, infinite sum. In that picture, it was clear that this this is the area bounded by y is equal to fx, x is varying from a to b, and x-axis. So this is area bounded by x is equal to a, x equal to b, and x-axis, and the curve y is equal to fx. And in a similar way, we can explain this as integration when it is with respect to y, and y is varying from c to d. So this is area bounded by y is equal to c, y equal to d, y-axis, and the curve x is equal to gy. So our it is like this. So this is fx a, this is a, this is b, and this is fx. So this is our area, this is our area. And if it is about function of y, our area is this one, it is about y, x is function of y. So it is like this, x is varying, y is varying, and it is drawn. So this is c, if it is c, if it is d, then this is area, this is the curve gy, y is varying, and corresponding to y we are having some values for, corresponding to this y we are having values of x here. So it is y, x is equal to gy, and this is the formula for area. And this and in this thing, you see, fx is negative, sometimes fx is negative. In that case, integration of fx dx, so suppose, so this is a, it is like this. Then suppose we have to find the area from this a to this b. So area, so it is here y is negative, that is why this becomes, the value becomes negative. So if we add this area, then this becomes negative. So this ultimately this becomes this minus this, but our area, it cannot be a negative value, and that is why we consider as the negative of this. So this is negative here, so negative of this is positive here. So it is just like the reflection. So we are considering, so instead of considering this one, this area, we consider this one, and we are adding this two. So this is the area integration of fx dx. So for this part, we are considering the modulus of this, or we may say negative of this. And this one fx minus gx, same value, mod of fx minus gx. So this is we consider the positive part, and we are discussing these problems. Region bounded by y is equal to x, y is equal to x, x-axis, x equal to 0, x equal to 4, bounded by y is equal to x plus 2, x-axis, x equal to minus 2, x equal to 2. Let us see this, how we are doing it. So this part, region bounded by y is equal to x, x-axis, x equal to 0, x equal to 4. So y is equal to x, we are drawing this diagram. So y equal to x is this line, so bounded by this line, then x-axis, x equal to 0, and x equal to 4 here. So this value is the, this is the area of this triangle, this is forming a triangle, and using this formula we are evaluating this one. So it is x dx, x is varying from 0 to 4 and it is 8 unit. Next one, number 2 is number 2. So this is also a straight line, which is y is equal to x plus 2, x axis, x equal to minus 2, x equal to 2. So this is y, we are integrating x plus 2 and this minus 2 to plus 2. So minus 2 here is minus 2, it is so it is no negative value, so minus 1 to minus 2 to 2. So this is the area here. Then number 3 is, so region bounded by y is x plus y equal to 4, x axis, x equal to 0, x equal to 4. So we are drawing this line, this is x plus y equal to 4, it is the area shows the region. So x, so this point, so this is the point 4 0 and this is the point 0 0. So x is varying from 0 to 4. Actually diagram is not perfect. This value and this value are same. So this is 0 4, this is 4 0, but it seems like these are not equal. Actually this value is equal to this value, and whatever it may be, our formula is this is not wrong. So it is from 0 to 4, 4 minus 6. So in place of where we are writing 4 minus 6. So this value is we are evaluating using definite integral. Then number 4, region bounded by y square is equal to x, y square is equal to x, x equal to 0, x equal to 1. So y square is equal to x, it is a parabola. So we are doing parabola. And here you see this parabola is symmetrical about y axis. So this x axis. So symmetrical about x axis. And we cannot have the value 0 to 1, it is 1, 0 to 1 and y. So y 2y we cannot have, only one y, one y. So this is 1, so means what, y is root over x. So it is having two values, one is plus root over x, other is minus root over x, and this is plus root over x. So we are considering integration of root over x, and because it is symmetrical we are multiplying by 2. So it is integration from 0 to 1, it is root over x dx, and we are evaluating it having this value. And thing is that we have to multiply by 2 because this is symmetrical, and this area is this area plus this area will give you only that this value bounded by x equal to 1. And that is why we are finding this area above x axis and multiplying by 2. So this is number 4. Next, number 5 is this is also same like the previous one. So here y square is equal to x and its lattice diagram is 1 by 4. So x is equal to 1 by 4. So this is lattice diagram, this is the parabola. In a similar way we are finding this value, but our limit is, in the previous case it was root from 0 to 1 and this time we are having from 0 to 1 by 4. So this is we are finding this value is bounded by y is equal to root over x. X is varying from 0 to 1 by 4, and then make it double and we will get the whole area. And number 5 is 5 we have done, it is 6, 5 we have done, so it's 6. It is region bounded by x square plus y square is equal to 9. So it is the circle, x square plus y square is equal to 9 is a circle, and this is the circle. So this is circle of radius 3, x square plus y square is equal to 3 square, so radius is 3. radius 3, and actually this also figure not perfect. It looks like ellipse, and leave it. We are assuming this is 3, also this is 3. It is a radius of the circle. So this curve is from this we find this this one, x square plus y square. So this one, and so y square, then y square is equal to 9 minus x square. So we are this, so this is function of x, this function of x. So it is y is equal to root over 9 minus x square. So this is our y is equal to, this means this is fx. Fx is equal to y is equal to this one. So y is equal to root over 3 square minus x square. So this is positive value, this is positive one, and this is negative one. So if this is our diagram, if this is our diagram, this is our diagram, then it is, this part is, sorry, this one, this part is, this is x equal to y equal to 0. So x axis, this is, so this part is y greater than 0, this part is y less than 0. So y is root over 9 minus x square. So first it is positive, and in the lower to the lower side, to the negative side. So this is negative, value is negative, and we multiply because it is symmetrical figure, and we require only the area, and that is why we find it and multiply by 4. Then number 7. So number 7, region bounded by the parabola y is equal to twice x minus x square and x axis. So this is a parabola, y is equal to twice x minus x square is x axis. So bounded by the parabola and x axis. So y is equal to this one, and x minus 1 whole square equal to minus y minus 1. So the parabola has vertex 1 1. So this meets x axis, this function, this graph meets in x axis at x equal to 0 and x equal to 1. Means what? Y equal to 0 when x is equal to 0, also y is equal to 0 when x is equal to 2. So this is 0, this is 2, so x is varying from 0 to 2, and it is always positive in this in this one. So we twice x minus x square. So twice x minus x square, we find this integration. So it is x square plus x cube by 3. So it is from 0 to 2. Also answer is 20 by 3. And this one. Then this one is bounded by same function, y is equal to twice x minus x square and lattice rectum. So we have to find this equation, u square is equal to minus v. We are transforming this. So u means x minus 1 and v means y minus 1. Means what? This is 0 0. 0 0 means this is this one. So this is 0 0 means u is 0, v is 0. Means what? X is equal to 1 and y is equal to 1. So 1 1. So 0 0 means it is 1 1, and it is the vertex of the parabola. And so we are having this vertex, and lattice rectum will be what? This is if this is a parabola, then lattice rectum is 4. What is that? 1 by 4 into 1 by 4. So it is 1. So so focus is 1 by 4. Focus is 1 by 4, and length of lattice rectum is this one. So at 1 by 4. So u is equal to v. So x equal to 0, x equal to 0. So lattice rectum lies on v is equal to minus 1 by 4. So if means what? We are writing this as v and this as u. This as u. So this as v. So v is minus 1 by 4. Minus 1 by 4 means to the lower of this axis, u axis, u. So lower of u axis means it is u plus u plus 1 by 4 equal to 0 or like that. So then y minus 1 equal to minus 1 by 4 and y is equal to 3 by 4. And what will be our limit? We are finding the value for the point of intersection of the lattice rectum and the this graph. So x is equal to 3 by 2, y is equal to half. The region bounded by the parabola is this one. 2y is equal to, so this is our main function, 2x x minus x square. Then y is 3 by 4, y is 3 by 2, y x is equal to half. So this value, and we are finding this area 2x x minus x square. It is y is equal to gx is equal to 3 by 4. Then this is number 8. And number 9 we see is y is equal to 3x plus 2. It is a straight line. It is a straight line. X is equal to minus 2, x is equal to 3. So x is equal to minus 2 means here. But here you see this value is negative. So because it is negative, we have to take the modulus of this. Modulus of this is minus of this. So area is this one. So for negative part is 3x plus 2. So it is minus 2 by 3 to 3. We have to consider this one. This is minus 2 to 2 by 3. This part is negative. So that is why we are considering the negative part. And from minus 2 by 3 to 3, this is the positive value. So for positive value, our value is 121 by 6, and for negative value, our value is 8 by 3. We are adding it and we are getting this result. Next one, bounded by y is equal to mod x. X equal to minus 1, x is equal to 1. So x is equal to so mod x, again we have to consider, because this mod x, here mod x we don't have any formula for integration. So this mod x we are writing like this. You draw the curve and this part is y is equal to minus 6, y equal to minus 6. So our function is y is equal to minus 6 for this part, minus 1 to 0, and from 0 to 1 it is x equal to y is equal to x. So by separating these things, so this integration, so first part is from minus 1 to 0, it is minus x dx, and the second part is 0 to 1 minus x dx. So answer is, it is half, it is 1. Then number 11, our function is y is equal to x cube. So y is equal to x cube, this is positive for this half when x is greater than 0, this is positive, and this is negative when x is less than 0. So this is our graph. So for this part, so from minus 2 to 0, we consider a negative of this. Or because it is symmetrical, we can write this. We can have this value from 0 to 2 x cube dx, and then we consider this part. So same value is here. So area is 0 to 2 x cube. It is 4, and so this value also is 4, because it is symmetric figure. Then number 12. So our graph is this. So it is a inverted parabola, y is equal to minus x square. So our region is y is equal to bounded by y is equal to minus x square, x axis, x equal to minus 2, x equal to 2. So this region we require by this curve and the line. So not inside parabola, it is outside parabola. So it is minus 2 to 2, this value. So y is equal to minus y. So we will consider minus 2 to x square dx, x square. So it is this one. Means what? We are considering like this. We are considering the curve. So this is our curve. We are considering its reflection on x-axis. So it is x square, then it is this value. So this one, it is inverted parabola. So this value. Then number 13, it is sin x graph. So this sin x, it is negative. We see sin x is negative when it is greater than pi and less than pi to twice pi. This sin x value is negative, and that is why we have to consider, because it is from 0 to pi, 0 to twice pi. So for this part we have to consider the this value minus of this. So area is sin x minus cos x for the region below x-axis. So this is below x-axis. So we will consider minus of sin x. So it is modulus of sin x. So it is minus of sin x for this, and the area is this 2. So similar is this thing. Cos x, our limit is from minus pi to pi. So we know the graph of this. So for this value we have to consider above x-axis, means its reflection on x-axis. So its reflection on x-axis, we are breaking up all these things. We are breaking up, and this region below x-axis, and that is why these are the value, and required area is 2 plus 2 equal to 4 unit. Fifteen is, so C16. So it is bounded by this one and this line, a circle and a line. So let us draw the diagram. This is the circle and line is here. So point of intersection we need to find. So y is equal to 4 minus x. Here y is equal to root over 16 minus x square, and that is why root over 4 minus x into 4 plus x. And their point of intersection is this 4 0 and 0 4. So it is we are integrating this value. So and for this it is bounded by two curves. So bounded by two curve means, so bounded by two curves. So this is one curve, this is one curve, bounded by two curve. Our axis is this. So bounded by this curve means we find first the area, this area. This area we find first, and then subtract this area. So we subtract this area. So integration of fx minus integration of gx. So it is 4x minus x square by 2. So the value is this plus this, and then region bounded by this y is x square is equal to 6y. So a circle and a parabola. Circle and a parabola, so is bounded by this circle and parabola. And our region, two regions we have to find. Two regions. First one is this one. So you consider the point of intersection of these two graph. So one is a parabola, other is a circle. So this is y is equal to 2. This y is equal to 2. So this above y is equal to 2. Our graph is this. So this is bounded by this circle and y is equal to 2. And this one is bounded by this y is equal to 2 and the parabola. And two parts, different parts are there. The region is divided into two parts. So it is for y lying in between 0 and 2. And we are finding this value. So it is this value y is we are doing with respect to y. So with respect to y is varying from 2 to 4, and this is y varying from 0 to 2. So we are adding this and getting this result. Then region bounded by x square is equal to y is equal to x plus 2. So this is a parabola, and we have to find the point of intersection of this. So point of intersection of this is x is equal to 2 and x is equal to minus 1. X equal to 2 and x equal to minus 1. The equation is this: x is equal to 2, x is equal to minus 1, y is equal to x plus 2. Oh yes, we are solving it from this 2. So this is x is equal to y is equal to 2. So this is the line y is equal to x plus 2, this one, and this is the curve, parabola. They are having it, and so it is from minus 1 to 2. X is varying from minus 1 to 2, and y is varying from this curve to this one. Then this one is the bounded by x square plus y square equal to 4, and this is the two circles are there. Two circles are there, and we have to find point of intersection of the two circles. So point of intersections are equation is this one. So pink area, it is from 0 to 1. So y1 0 to 1, this is also 0 to 1. Shaded area for minus, for instance pink area, this is blue area, is from 0 to 1. This should be 4 minus x square. So this is let's say this one is 1 to 2. No, this is not 0. This is 1, and this is 2. 1 to 2. 1 to 2, and we are finding this value separately and then adding it. So this is our result. And number 20, this is the last one. So two curves. So we need this one bounded by the two curves. So we need this one. So this is from 0 to 1, and then this one is greater. Y is equal to root over x is greater than y is equal to x square. So this is greater, and our integration is from root over x square minus root over x minus x square. So answer is 1/3 unit. And number 15. Number 15 is the figure is symmetrical about both the axes. So this is an ellipse. It is an ellipse, and this thus area of the circle. So area of the circle is this one. Thus area of the circle from 0 to 3 say region bounded by this one. So this is this one. This is not circle, this should be ellipse, I think. Ellipse. So area of the ellipse is 4 into this value. So this is our value 6 pi for this ellipse. So this is all about the this is all about this the area of the area with the help of definite integral. Thank you.